Hello everybody, welcome back to VBA Lesson 8. In this video, I will talk about Ohm's law and the resistance in series and parallel circuits. This is a file that you can download from the online course shell. So let's look at Ohm's law first. To simply put it, Ohm's law states that if we know the resistance and the voltage in the circuit, we'll be able to get the current by dividing the voltage and the resistance. In a series circuit, to get the overall resistance, we only have to add up all the individual resistance. In a parallel circuit, it's a little bit different. First of all, we have to get all the reciprocals of all the resistance, and then we'll have to put a 1 over the sum of all those reciprocals to get the overall resistance. So we will write 3 different programs and 3 different functions for these 3 different tabs. Okay. Let's start by going to the Developer tab, clicking on Visual Basic, Insert, Module, like we always do. Module 1, I am going to change this to Ohm, okay, so that we know that this is for the Ohm's law, and then we will also do series and parallel later on. So ohms for this. Okay. So let's start writing our program. The first line should be option explicit. Alright. And then I will do a function. This function will be calculating the current from voltage and resistance. So I will do current. I have 2 variables of voltage and resistance. I will declare V as double and R as double as well. The overall function should be as double. Right. To calculate current, we have to have this formula: current equals V over R. Okay, that looks good. The next step is to write our function, our program. So sub, I'm gonna call my program test current. Parentheses, don't forget about that. And we have to declare the variables. So I have 2 variables over here, V and R. Then V as double, then R as double. Okay. Alright. So just like before, we will use a message box to ask the users to input the information. We'll ask them to input the voltage first. So V equals input box. Okay. In this box, we want to ask them to enter voltage. Alright. Very similar to the voltage, we will ask them to input the resistance as well. Let's do that and change this to R and enter resistance. So take advantage of the copy and paste option. It's very helpful. Saves you a lot of time. Okay, and after we have the information for the voltage and the resistance, we can calculate the current. So we'll let the user know that what it is. Message box, okay, current equals a little blank space between and current. So I am calling the function up here that I wrote. It's a current function, and this function has 2 variables, V and R. Okay. Alright, that should be okay. So let's go to the Ohm's law page and put in a button here so the users know where to click. Alright, I'm gonna link this to test current. Okay. And we'll rename this as calculate current. Right. Let's try it out. Alright, message box is here and enter voltage. Okay, I'm gonna put in something really simple such as 6. Okay, I'm gonna put my resistance as 3. So if everything is right, I should get 2 as my answer. Okay, my current is 2. Very good. So let's go back to our module here. Now we have the module for the Ohm's law, but we still have two different tabs that we have to deal with. So let's create another module by going to Insert Module. Now we have a new module. We will call it Series. So change the name to Series. So get that you know that this is for ohms and this is for series. Okay, for the series one, I'm gonna copy and paste this because I can use a lot of this stuff. Okay, go to my series and paste it. All right. So let's start making changes to the series program. So first of all, first line it's gonna be option explicit. Okay, don't have to change that. My function is not gonna be current anymore. My function is gonna be series. So do you remember how to get the series, the resistance for series? You just add up all the resistance. Okay. So keep that in mind. My series function, I'm not gonna have V and R and all that. I will, however, have R1 and R2 and R3. Okay, R2. One more. Gonna put R3 as double. Alright. So that looks good, and my formula is gonna be different. My formula is gonna be series equals R1 plus R2 plus R3. Alright. Once we have that, this function is complete, but we still have to write a program for it. So the program will be test, to make it easy, test series. Okay. I'm going to declare my variables, that my variables are going to be R1, R2, and R3 instead of V and R. So let's change this to R1, second one to R2, and add one more. I am going to copy and paste this. Okay. Paste it. R3 is double as well. Okay. Now you want to ask the users to input R1, R2, and R3. Okay, after all that, so change this to R1. Enter R1. So we can copy and paste this 3 times. 2 times. Okay. So we have 3 resistance. 3. Sorry, 3. Enter R2. Enter R3. Okay, make sure they match. Alright, that looks good. And in the message box, we want to tell people the overall resistance is equal to, this function is not going to be current, it's going to be series. So call the series function series, and then my variables will be R1, R2, and R3. R3, R2. Okay. So that should be okay. Let's check our work by going back to the series circuit page. Insert a button. So I will link this to test series. And I'll change this to calculate series resistance. Alright. Click on this. Enter R1. What would my R1 be? How about we just set them all to 2? And if the calculation works out, we should have 6 as the answer. Okay, so 2. R2 is 2. R3 is 2. Okay, resistance is 6. Perfect. Okay, so that was for series. Let's do the last one, parallel. So parallel is a little bit more different than the last one, but we have a lot of code that we can still use. So what we can do to save time is to copy and paste all the series code. Okay, copy it, and then I want to insert a new module and call this one parallel. Alrighty. So parallel, I'm gonna paste this, okay. And let's make some changes. My function will be called parallel. Parallel. Alright, I will still have 3 different resistance, R1, R2, R3, so I don't have to change that. However, my functions, my formula is going to be different. So it will be parallel equals. Okay, so remember what the formula looks like. We have to put a 1 over all the reciprocals, sum of all the reciprocals. So let's write out the reciprocals. So 1 over R1, okay, adding to 1 over R2. It's always a good habit to include the parentheses just so that it's clear which quantities are separated. Okay, so 1 over R2, and then we have one more, 1 over R3. Okay, close the parentheses, right? Check the parentheses by pairs. So 1, 2, 3, 4 with 4 pairs. That's good. Next up, change this to test parallel. Test parallel. Okay, and we still have to declare R1, R2, R3. So those are done thanks to the series code, and we still have to ask the users to input R1, R2, R3. Okay, and that's done as well. So that really saves us a lot of time. Not having to type out this. Overall resistance will be calling the parallel function. Parallel. And R1, R2, R3 are still the variables. Okay. Now we have the parallel code. Go back and check it. A button again. This button will be linked to the parallel function. With the code. Okay, so calculate parallel resistance. Right. Let's see if it works. Let's do something really simple. If I put in 2 for R1, R2, R3, so 3 2s, I will be getting 0.66. Okay, so I already did the calculation, and if everything goes right, I'll have 0.666. Alright, so I'm gonna put 2 here, and 2 here, and 2 here. Okay. My overall resistance is 0.6666. It goes on. Okay. So I know that I did it right. Let's go back to the module a little bit. It's very important to separate your codes and name them. If you have like maybe 20 different modules, it's easy to find which one you're looking for. And just a final reminder, you always want to save this as a macro-enabled workbook.